So I really want to talk about this congruence with you guys. We have x to the x power is congruent to 2 mod 5. I will have to first tell you though, I don't know how to solve this kind of things in general. First, we cannot use the Lambert W function. I know when we see x to x power, we solved an equation before in that form, but here, this is about modular arithmetic. The answers will be in integers. Alright, another thing I want to tell you is that I picked the number 5 because it's a nice prime number. If you change this to a composite number, such as 6 or 8 or 25, I don't know how to do those things. In fact, if you change the prime number to the prime number 7, I also don't know how to do that one either. Yeah, this right here gets crazy pretty fast. But I did spend a lot of time on this one, so I wanted to show you guys what I know. Especially, I don't think anyone has ever done this on YouTube, where we have the base is x and the power is also x in a congruence. So I hope this video can create some good discussions, because I think this is also pretty interesting. Here we go. For the congruence, it should mean that the left hand side and the right hand side will have the same remainder when we divide it by this number. So, for example, 36 is congruent to 1 mod 5. Because 36 divided by 5 is 7 with remainder 1. And of course, 1 divided by 5 is 0 with remainder 1. So that's why they are congruent to each other in the mod 5 world. And we can also say 9 is congruent to 24 mod 5, because this will give us remainder 4, likewise this right here as well. And just consistency purpose. Now, we can also have negative numbers, and those right there will be a little bit trickier. If I say negative 2 is congruent to what mod 5? One way to do it is that you can start with negative 2 and then just keep adding 5 to it. Negative 2 plus 5 is 3. So you can say negative 2 is congruent to 3 mod 5. Using this idea, in general, A is congruent to B mod n. A better way to represent this with an equation is that we can write A being equal to some multiple of n. We'll just write it as k times n, and here k has to be an integer, and then we add the b to it. So this implies that, and of course we can also do it backwards. This right here, it might be easier to work with because this is the usual equation that we are more familiar with. And this congruence, well, I haven't done a video on this for a while. The last time I did a video on this probably was in 2019. So, we'll see. And then along the way, I'll also give you guys some more facts. Okay, here we go. At first, when I thought about this congruence on my own, I thought, it's supposed to be easy, right? Because I only picked mod 5, meaning, in fact, we just have to consider 5 numbers. Because in the mod 5 world, technically we just have 0, 1, 2, 3, and 4, because these are the 5 different possibilities of remainders when you divide a number by 5. Let's just go ahead and plug them into the expression and see if we get remainder 2 or not. First we have 0, but I really don't want to put down 0 to the 0th power because that everybody say nobody likes it. So I'm going to start with 1 first. If we have 1 raised to the first power, usual math says that's just equal to 1, which is congruent to 1, but of course this is not congruent to 2 mod 5. So 1 is not an answer. Now I'll check 2. 2 to the second, usual math says that's 4, and of course that's not congruent to 2 mod 5. Now check 3. 3 to the third power worked out, that's 27, usual math, but let's put down the congruence. And then 27 divided by 5 is 5, which remainder 2. So it does work. So it looks like 3 is an answer to it. And then let's keep going. 4 to the 4th power. Now, this is a slightly bigger number. Here, this is what we can do. In the mod 5 world, when we have an exponential case, we can go ahead and look at the base and mod that first. 4 it's congruent to -1 in the mod5 world. Right? 4 is congruent to -1 in the mod5 world because, like what we said earlier, you can start with this and keep adding 5 to it, or you can start with this and keep subtracting 5 to it. 4 minus 5 is -1, so they are congruent. So you can mod the base, but the power, you will have to keep that. A quick reason for that is, if you expand this, of course, that's 4 times 4 times 4 times 4. And one of the facts about modular arithmetic is, you can go ahead and mod each numbers when they are multiplying, right? So that's one of the facts. So if you have the 8 right here, you know, you cannot just mod 8. It's very different. You can only mod the base. Now, if you did mod the base, you have -1 raised to the 4th power. It's much easier. This is just going to be 1. Okay, that's not congruent to 2. Mod 5. Lastly though, I still have to check the 0, but let me just check 5 to it. Alright? And then that will give us 5 to the 5 power. Well, let's do the same thing. I'm going to mod the base. If I mod the base, this right here is 0, and then to the 5th power, this is just 0, which is not congruent to 2. Mod 5. So if you take a look, it looks like this is done. The answer is just 3, right? And by the way, I do want to show you guys real quick, just to really emphasize, because it would be so nice if we could also have mod the power, but it's not. 4 to the 4th power, right? This, I can say that's the same as -1 and then raised to a -1 power, right, in the mod 5 world. This right here is, as we said, is 1. This right here doesn't mean anything. You cannot have -1 power. But yeah, just trust me, do not mod the power, alright? I really wish we could, but no. Anyways, the answer looks like it's just this right here. So 3 to the 3, right? So that's when x is equal to 3. So it looks like we have x is congruent to 3 mod 5. Done. No. Why not? I will tell you, 3 does work. 3 does work. It's an answer. But this is not the only answer. In fact, this is actually incorrect too, because it's not 3 mod 5. What I mean by that is the following. If you say x is congruent to 3 mod 5, then you are also implying that x could be equal to 8 should also work. But does it? Have a look. Put the 8 into the original, we get 8 to the 8, and then let's just work that out. Remember, we are going to mod the base first. 8 mod 5 is 3, and then we have to raise that to the 8th power. And then I can actually do this again, because 3 to the 8th power is a little bit too big. If I do -2 to the 8th power, that I remember is 256. And then look at the last digit. You get 1 mod 5. So as you can see, this is definitely not congruent to 2 mod 5. So in fact, 8 does not work. But if you write this down, you're implying 8 does work. So what do we do? What's wrong with this? So I was really confused too. I thought it was going to be easy, but no, life is not easy either. So I went to my best friend, not ChatGPT though, I'm sorry, but WolframAlpha. And I'm going to write down the answer that we got from WolframAlpha first. Right here, I will tell you, if you use WolframAlpha, the answers are, we have 2 sets of solutions. The first one is x congruent to 3, but it's not mod 5, it's mod 20. And the other one is x is congruent to 17, mod 20. We have two sets of solutions. And now you might be wondering, how did we get the 17? Is it just 20 minus 3 gives us 17? I'll tell you no. If, in general, right, that's not the case. If you change the 5 to a 7, that's not the case. Okay? So, what's going on, right? Okay, so here's the time I did more observations, and this is what I did. Let's talk about it. Right here, I started to think. And the best way to think is just to make some observations to see if we can find some patterns. Right here, the key is we have 2 to some power, 2, right? And then this is with powers. So I decided to take a look at 2 to the powers in the mod5 world. Let's have a look. If I start with 2 to the 0, let's not look at 0, that's just 2 to the 1. Yeah? So 2 to the first power is equal to 2, of course. So they are congruent to each other, mod5. Now if I do 2 to the second, this right here, usual math says it's just 4. And then it's all mod5. 2 to the third, it's 8, but if you mod 5, you get 3. Yeah, and then if you do 2 to the fourth, this right here is just going to be 2 times that, which is 6. Well, actually, let's do it like this, 16, and you end up with 1. Okay, now, here's the interesting part. If I keep going, 2 to the fifth power, that's 32. And then we will get 2 back, right? And these are all mod5. I don't need to keep going anymore because it's just going to be 2, 4, 3, 1, 2, 4, 3, 1, 2, 4, 3, 1, repeating. Now, how long does it take for them to repeat? Starting from 1 up to 5, the gap is you have to add 4 to it. Here's a fact from the observation. If you have 2 to some power, let's say x, is congruent to 2 to another power, let's say y, in the mod5 world, what does that imply? What's the connection between x and y? Well, if you look at 1 and 5, they differ by 4, right? That's the hint. In general, I can say x will be congruent to y, but in the mod4 world. So the next one, if you want to get the 2 back, you have to go 2 to the 9th power, and you will get 2 back. And so on, so on, so on. That's pretty cool, huh? All right, in fact, I will show you guys the more general form right here. If today you have some base b raised to the x power, it's congruent to base b raised to the y's power. Let's say it's just mod a prime number p, right? This right here implies that x has to be congruent to y, and then you guys can kind of just play around with this. We'll just test things out, make some observations. It's going to be mod p minus 1. Of course, there's the theorem behind this, and you can also use the so-called Fermat's little theorem and all that stuff, but I don't really do number series videos, so I think this is the easiest way for me to deliver the concept to you guys, right? So I'm going to utilize this observation and also this fact to help us out a little bit. At least this is what I did. So let's see what can we do next though. I'm going to see how to get the first answer right here. Okay, so firstly, as we saw earlier, what we do know is 3 to the third power does give us congruent to 2 mod 5. So instead of the 2 right here, I'm going to purposely write it as 3 to the third power. So this means we have x to the x power congruent to 3 to the third power mod 5. Here's the deal. I'm going to focus on the exponent here. I'll make them red, and of course the base. Now, here is the part that I'm not sure if it's entirely true or not. So if you do know, please let me know in the comment down below. If you have the exponent, I just ignore it. Right here, what I want to say is, this should imply, this right here should imply, as I said, I'm not entirely sure, but this right here should imply that I can just make sure the base are congruent to each other. I'm pretty sure that does not give us, this part right here does not give us all the solutions. I will have to admit that, okay? But I already told you I'm not sure how to solve this in general. This is just what I did. I'm going to make the base congruent to each other mod5, because if you didn't have the exponent, that has to be the case, yeah? So this is the first condition. Now, the second condition is what we went over here. I must have x is congruent to 3, and remember this, it's going to be 1 less than the prime number. So right here, and also put down this right here, right? B and B. Right here is like x and 3, so I just don't feel that it's right, but I can't really find too much information online, so anyways. Secondly, x should be congruent to 3. Now, mod 4. Now, let's think about it. How do we solve this? It's not so bad, because right here what we're saying is, when you take x divided by 5, you get a remainder of 3. If you take the same x divided by 4, you also get the remainder of 3. So what does that mean? These two together should imply that x will give you remainder 3 when you divide it by 20. 5 times 4 together. So I can write it as x is congruent to 3 mod 20, and that explains the first one. So this is just a quick way to do this one. Now, for the second way, well, for the second piece of the solution, I'm going to do it slightly more rigorous for you guys. And it will be the same idea. Okay, now I used the 3 already. Here is what we are going to do next. We did the first part, now for the second one. Here we have x to the x power is congruent to 2 mod 5, yeah? I'm going to give the 2 some exponent. I don't have to be fancy. I don't have to say that's 2 to the 5th, even though we could, but we don't have to. Just go ahead and do 2 to the first power. And then mod 5. Now, right here, I'm just going to do what we did earlier. I will say x should congruent to 2 mod 5, and this is our first condition. And second condition is that if you look at the exponent, x should be congruent to 1 mod 4. And for this one, I'm going to do it more rigorously. And for this, we can get a second equation, second set of solution. For the first one, I'm just going to change that to an equation. X will be in the form of some multiple of 5, so I will put down 5k and then plus the remainder 2. And then I'm going to put this right here and say that's 5k plus 2 is congruent to 1 mod 4. And then we'll just solve for k from here and then plug back in. Subtract 2 to both sides, we get 5k is congruent to -1 mod 4. And right here, if you don't want to work with negative number, you can just add 4 to it. So you can say that's congruent to positive 3. Now, 5 times k is congruent to 3. Do not divide both sides by 5. We don't have fractions in the modular arithmetic world. But instead, here is the key. Note that 5 is congruent to 1 mod 4. And remember, as we mentioned earlier, if they are multiplying, you can just mod the first and then mod the second and then just put them together at the end. Right, multiply them together at the end. So this right here is just going to be 1 times k. Just like that. Now, this means k is congruent to 3 mod 4, so we can say k is equal to some multiple of 4. I used k already, so let's use L, which is also an integer, and then plus the remainder 3. And then I'm going to put that back here. And then let's just solve it. Just simplify it. As you can see, that's 20. L, that's 15, and then plus 2, which is plus 17. So x is equal to 20L plus 17, which means that we can say x is congruent to 17 mod 20 if you do it backwards. And that explains the second one. So at this point, I was pretty happy because yay, it seems that I solved it. But truth to be told, how did I get the 3? Technically, I kind of just plug in the numbers and check, right? I think when you are dealing with congruences, there oftentimes that you have to just plug in number and check. I think that is a method. But I'm just wondering that can you really figure out the 3 without guess and check? In fact, for this one, just by accident, I will say, because this method does not work if you have like any other numbers. If you kept it as -1, right? If you kept it as -1, then this would have been -1, and then that would be 5 times -1, which is -5, and then plus 3. Plus 2 is... Oh, that doesn't work, that's -5. See, it doesn't work. What am I talking about? Let's just not talk about that. Anyways. Yeah. I don't even know how to get the 3 besides guess and check. Okay, and just to show you what will happen if you change this to a mod 7 and then the number being the same. Take a look at the screen. Yeah, you have so many sets of answers. So, is there a general way to always solve this kind of things? I don't know. Did I really solve this? Or I'll leave that to you guys. But I hope you guys all like this video though.